Alright, today we're going to start section 9.5, which is going to be graphing the sine and the cosine curves. This should not be new to you. However, we are going to cover all the details. Before we get into the sine and cosine curves, though, we want to see how it relates to every other every other function that we've graphed. So if you have y equals negative 3 f of x minus 2 plus 5, pause the video and write down how the shifts and stretches are going to be affected from the f function to the y function. Pause when you're ready to check. Okay, hopefully you said there's going to be a horizontal shift to the right 2, or if you said add 2 to the x values, that's fine. Multiply the y values by a negative 3, or if you said vertical stretch, plus there's going to be a reflection over the x-axis. That's what multiplying the y values by negative 3 will do. And then there's going to be a vertical shift up 5, or you could say add 5 to the y values. Now we want to make sure we understand that in this sort of notation, because this is exactly what relates to the trig functions as well. Alright, so again we're going to look at, sorry about that, that's 9.5, graphing the sine and cosine function. So we want to understand period, amplitude, and phase shift for sine and cosine. So first though, we're going to look at a demonstration. You've probably seen something like this before, maybe not. But here we can see how the unit circle relates to the graphing of trig functions. So if we see the unit circle, we see an angle theta, we have some point on the circle, we'll show the arc angle, and so now first if I just animate theta, we can see as we go around the radians are going to increase, and we can continue to go around the circle, and the radians continue to increase. Okay, great. Well, what do we know about sine and the unit circle? Well, we talked about the fact that sine relates to the y value on the unit circle. So if we look at the y value as we go around the unit circle, so now I can see the y values go up and down, and they just keep cycling between negative 1 and 1. Well, what if I plot that point, or those points, as I go around the unit circle? So now this blue curve is all of the y values as the x-axis is theta increasing. So we can see this is what the sine function looks like. Up to this point right here where I have the cursor, that is one revolution or one period of the sine function. Remember we talked about periodic functions, so sine and cosine are periodic functions, which means that they're cyclic, or they're just going to continue on forever. So I can see that that's going to continue on. If I speed this up a little bit, I'll see that as theta starts to come back, that the graph doesn't just start at the point 0, 0. So the curve is also going to go off in the negative direction as well, as theta goes around the curve in the negative direction. So this is how we can develop the sine curve. Okay, so now to look at the cosine curve. So again, we'll do the unit circle, the angle theta, show a point, we'll show our arc angle, but now we know that cosine is the x values. So if I show the x value, well now as I animate theta around the circle, I can see that the x values are going to just go between negative 1 and 1, and we know that already. But here we can just see a visualization of that. And so now if I plot those x values though, just like I did with the y values, now I can already see this point here, that the x value is at 1, so now the y value of the curve is going to start at 1. And so now I can see this is the trace of the cosine curve. And here, I tried to stop it, it's pretty close. This is 2 pi. So that was one period of the cosine curve. And so as we continue to go around though, then you'll see this cyclic pattern that forms for cosine, just like it did for sine. And same with sine. If we speed this up a little bit, we can see now that as this is going to come backwards, that the curve is going to also go off in the negative direction as the angles become negative 2. So the cosine function, we can think of the first period starting at the point 0, 1, but we know that the function itself is more than just starting at 0, 1. It's actually continuous forever in both directions. And if we want, we can overlay the sine curve here, and we can see the relationship between the two of them. And this also helps us see the cofunction identities. So we know the cofunction identities are showing that the sine and cosine curves are just a phase shift of pi halves, or 90 degrees from each other. And so we can visually see that here, that the blue curve is the exact same curve as the red. It's just shifted over pi halves. And so that shows us a better representation of our relationship between sine and cosine. Okay, so now we want to go through some definitions. So big one, amplitude. The amplitude of y equals a sine of x and y equals a cosine of x represents half the distance between the maximum and minimum values of the function, and is given by amplitude equals the absolute value of a. So notice a key thing here is that it represents a distance. So amplitude is always going to be a positive value. A does not necessarily have to be a positive value. Another way to think of this is this is our vertical stretch or shrink. Think back to, you know, the warm-up that we looked at where we had that -3 in front. That -3 would have been our A value. Next thing is period. So period is one complete cycle. Remember, these are cyclic functions, so they continue on forever. So we let b be a positive real number. The period of y equals a sine of bx, and y equals a cosine of bx is 2 pi divided by b. So if there is some number multiplied by x, then we do 2 pi divided by that number to get the period of the new function. Now that should make sense because in our standard function, y equals sine of x, for instance, the b value is 1. And we know that the period of sine, because we talked about this earlier, is just 2 pi. So if b is 1, then the period is 2 pi. If b is something else, then that period is going to change. And so this is going to be our horizontal stretch or shrink. So for the basic functions, y equals sine of x and y equals cosine of x. Well, what is the amplitude? Well, the a value in both of these is 1, so the amplitude is going to be 1. The period, well, b is 1 for both of these, and so I just mentioned, and the period is going to be 2 pi. Again, we talked about that earlier. What is the domain? Well, here we want to think about, you know, if we think about that graph that I showed you, the functions continue on forever, and we know because of the idea of coterminal angles, you can keep going around the circle forever. So the domain is going to be negative infinity to infinity, or all real numbers. What's the range? Well, again, we're specifically talking about these two basic functions. So the range of these functions, well, what are the output values? Possible output values are anywhere from -1 to 1. And so if we think about that picture of that graph again, it just cycles between -1 and 1. Okay, let's expand this generic function a little bit further to include shifting. So if I have y equals a sine of bx minus c and then plus d, the d can go in front, that's the same thing. Or same with cosine, y equals a cosine of bx minus c and then plus d, or the d in front. Now the amplitude, we already talked about this, is the absolute value of a. The period is 2 pi over b. The horizontal or phase shift is going to be what? Well, think about, again, our other functions that we've dealt with, and it's going to relate to, well, what is in the parentheses, and in this case it's going to be c over b. Now we have to be careful and understand that this is a minus c, so it's going to shift in the opposite direction. Another way to find the phase shift is if you set bx minus c equal to 0 and solve for x, then you're always going to get the direction of the shift correct, because that x will represent the correct shift. The vertical shift then is just d. So if d is plus 1, then you have a shift up 1. If d was minus 5, then you vertical shift down 5. So, graphing strategies. This is what I would recommend. This is not what you have to do. First, I would find the vertical shift. So, the reason why I say that that's the first thing you should find is because that's going to represent our new horizontal axis. So everything is going to be revolve about that axis. That's going to be what the function is cyclic about. Next thing we want to find is find the amplitude. Because this is going to tell us from this horizontal axis how far up and how far down do we go. Next we want to find the starting value, and by starting value I mean, remember, so the functions are continuous forever in both directions, but when we graph this we have to start somewhere, and so that starting value is going to be our phase shift, or our horizontal shift. So that's going to tell us what x value we want to start at. After that I would find the period, and then find what I'm going to call the intervals. And the intervals are what we use to help us graph. And the intervals are period divided by 4. And what that is, we'll look at this when we actually graph, is we can evenly separate points on the graph in order to easily graph a function. And then the last thing is plot the points for the period. And it's going to be 5 points. I'll show you that when we actually do a graph. So 5 points is going to be 1 period, 9 points is going to be 2 periods. The reason is because they connect to each other. Now for sine and cosine, we also need to know what does the basic function look like. That's 1 period of sine, and cosine looks kind of like that for 1 period. Okay, so we want to graph 2 periods of y equals 3 sine of 2x. So let's go through our strategy. The vertical shift is going to be 0 because there is no plus d. The amplitude is 3. Period is 2 pi over 2, which is pi. The horizontal shift, which is also our starting value, is 2x equals 0, so x equals 0. Our intervals are the period divided by 4, so that's going to be pi over 4. Okay, so now we can start to draw the graph. So since I have a vertical shift of 0, I'm going to center everything around the x-axis, and since I have a horizontal shift of 0, I'm going to put the y-axis to the left. Now from here, or actually we're running out of time, so I'm going to pause, or I'm going to stop it here, and then I'll pick up this example on part 2.